Okay, a small introduction. Ron Schott is at Fort Hays University, and I'll tell you a little bit about him. Ron Schott is one of the original pilot scientists in the flight program, and he's worked to push the limits of GigaPanning since the fall of 2007. That's true. He's taken more and bigger at many points in time than anybody else. And he's created the world's first full Gigapixel anaglyph three-dimensional GigaPan. And we have currently more public GigaPans on the GigaPan.org site than any other sold. And it's in pixels. And it's more than 600 gigapixels, more than 700 actually.
It's 858.24.
858 gigapixels. So soon you'll be a terapixel man. I'll need a terapixel work. Go ahead.
So yes, this is my rebuttal to the earlier slide about the rise of the site and my own contribution to it. You can see that I'm trying to use the mic. Am I not speaking into the mic? Is it not coming up? I'll wait a second until I figure it out.
Just wait 10 seconds.
Sure, no problem.
Just for recording, please.
That's fine. Want to mic me with this one? Should I? Come on. Oh, is it ready? Yeah. Okay, very good. All right. So yeah, I just had to back up those numbers and show you that I am indeed part of ELO's problems with the disk drives, and hopefully not going to let up anytime soon. At any rate, how did I get into GigaPanning? It turns out I got involved with GigaPanning via Google Earth because I was actually interested in making virtual field trips in Google Earth, and this is one that I presented at the GSA annual meeting in 2006 in Salt Lake City, Utah. And this was a virtual field trip to Dinosaur National Monument. And I'll just give you a brief taste of what I had been working on beforehand. There's an overview, and you can fly this as a tour in Google Earth, but this is just some of the geology here. Since you're here for geology, I figured I'll give you some geology too. That's the Split Mountain Anticline, and it turns out that that's part of where Fort Hays State University does its geology field camp during the summer. And here you've got the Green River flowing right through Split Mountain and antecedent drainage. And I had put together a number of stops along the way here. The first are just overview stops. You can come into Split Mountain Anticline and Google Earth stuff, right? The dinosaur quarry, actually this leads into the GigaPan discussion. It'll take this a second to load, but this is what I was doing before I was GigaPanning, which is QTVR, QuickTime Virtual Reality photography. And this was definitely not a roboticized process. I have a pano head that you have to move around step by step. And this is inside the dinosaur quarry, and of course this is really useful right now because the dinosaur quarry building here has been closed because of structural problems just a few months after I shot this. There's a limited amount of zoom here, but you see that very quickly this becomes highly pixelated, and you really don't get the sort of detail that you'd like to have. Just going to stop one more stop. We'll move over here to Redwash. The first stop, this is on the geologic mapping area that we actually do at Fort Hays. It's just a section of the south limb of the anticline here, and I've got the geologic map overlaid in Google Earth so you can see the geology interpretation on top of the topography. But this is another QTVR, and this is the view from the top of the ridge there, looking back toward the dinosaur quarry. And if you look somewhere off there in the distance, the dinosaur quarry must be out there. I'm sure we'd see it if we zoomed, or maybe not, because in fact that's about the extent of the zoom. So when I first discovered GigaPan via Google Earth, I got very, very excited by this. And in fact, this field trip is now one that I haven't done a whole lot more with, but oh, that's not the one that I want. This is, in fact, one of the GigaPans that I've shot since I got there, and this is from the same vantage point that I shot the QTVR shot. But in this case, we can zoom in a little further, and there it is. There's the dinosaur quarry. the fossil bone quarry along the Dakota Sandstone Hogback Ridge there. And this is not the full 360, but you can get, of course, the feel for the power of GigaPans through this. So I've shot quite a lot of GigaPans, over 700, and it was very hard picking GigaPans to put in this talk. So the first thing I actually did was, well, that's my office. That just shows that I'm a geologist and I've got a messy bookshelf and lots of desk crops and things like that. And we can explore that at our leisure later on. But what I wanted to do was start with, you know, the first thing I think, oh, there's another dinosaur national monument shot. I think the first thing a lot of folks think of when they think of GigaPanning is to immediately go to these beautiful big landscape panoramics, and I'm certainly not immune to that. This is a small portion of a wider view that I shot this summer at Monument Valley in Arizona, or on the Navajo Nation rather, and on the Utah-Arizona border. And of course, this is the classic view that you get of Monument Valley, the mittens with Merrick Butte over here. And the great thing about a GigaPan is you don't necessarily get a sense of scale when you're looking at this thing from a distance until you zoom in and find some automobiles down there. And that really is a valuable thing as a teaching tool, as a general thing, to really remind you that these are really huge sorts of features. My biggest GigaPan up until about a month ago was this one that I'd shot at Mount St. Helens. This was 2 summers ago, and this is almost an 11 gigapixel image. And this is shot from Windy Ridge looking out to the west in the hours just after dawn. It took about it took about 2 hours to shoot this one. This is 1900 input images. You can zoom in and see the crater glacier very nicely. You can see the stratigraphy on the back wall of the crater that was formed May 18th, 1980. We can zoom around here and find, and now I'm going to get lost, there it is, Lewitt Falls. Lewitt is, of course, the Native American name for Mount St. Helens, and that's Lewitt Falls. So there's really great things that you can find when you really zoom in here. Of course, the Johnston Ridge Visitor Center over here in the distance. Now, of course, I wanted to GigaPan from that spot, looking up into the crater, the classic view, and the day that I shot that GigaPan, the mountain was clouded in. So I'm not going to show you that. But all kinds of fun stuff, like the log still that cover Spirit Lake. This is 20 plus years after the eruption, and you still have big rafts of logs floating around on the lake. And then there are other things. Of course, you can see the blast damage. If you move out here, you can see trees blown down in a number of places, all radiating out away from the blast. You can survey the whole landscape and see a lot of this. You can see the revegetation, the regrowth, how the area here on the spur of the ridge in the foreground was protected from the blast somewhat, and you've got a lot more regrowth there than on the opposite side. You can make out features of the pumice plain and the delta down here. You can see sedimentology features running down through there. We could go on and explore this, I guess, all day. But anyway, so landscapes certainly make for great GigaPans, and I certainly would not dissuade you from doing that. But getting a little closer to the rocks is also very valuable and has lots of great geologic applications as well. This is a road cut in south central Utah. These are the Henry Mountains in the background, and of course if you want to go and look at the Henry Mountains you can do that, but the really spectacular geology that's exposed in the road cut here, I mean, this is a lesson all in itself in geologic time. Basically I could set students down with this thing and say, interpret the geologic history of what you can see in this road cut, and I would certainly expect them to begin to trace out some of the stratigraphy. Notice all the little faults running through here. Of course, my field assistants were there for scale. And there's Eddie. Bertie's around here somewhere. There's Bertie. See, Bertie's actually pointing to the fault right there next to him. And I should point out that obviously putting scale into your field photos is very important and can actually be really engaging for the students too if you do it in a fun way. And then you got the spectacular alluvial fan deposit sitting on top of this, and an old channel deposit right there, and I could go on, but moving in a little closer, of course, GigaPans are also great at showing smaller features. Now, this is a piece of Gordon Lake Formation from central Ontario, and this was a piece of float that I picked up off of a talus slope, brought it back, and I've used this actually in a number of sedimentology classes, just looking at the details of this, and it's a big lug of a piece to carry around, but with Bertie and Eddie looking on there, we can see that if you zoom in, you can begin to see features like, well, first of all, the bedding, and then the question becomes, is that bedding upright or overturned? And if you're a geologist, you'll note these beautiful mud cracks seen in cross-section with the opening on the top, and we can tell that that's now correctly oriented with up, direction up. And if you look in here real closely, you can see little features like, again, little channels. I don't know if you can make out the cross-bedding in here. There's a little faint cross-bedding. There's some rip-up clasts down here that Bertie's pointing out. And anyway, there's all kinds of things. And of course, if you've got the sample there in front of you, you can certainly examine it. And this doesn't replace that experience, but it certainly does give you the ability to transmit it over a greater distance. Want to go a little bit smaller? We can go smaller. So this is a microGigaPan. Richard Palmer taught me all I learned about microGigaPans, and I remembered to put a scale bar in this one, and it's always fun to go ahead and zoom in so that a millimeter is the entire field of view. And you can begin to see things that normally a geologist would look at with a hand lens, and you'd be able to see one little tiny bit of the rock with the hand lens, but now we can zoom in and see, oh, look at the light reflecting off that plagioclase feldspar. You probably wouldn't see that if you had the hand lens up to the rock because you'd be blocking the light. But there are the striations on the cleavage surface, so I know that's plagioclase. Where do you go beyond a macro hand sample? Well, you go to thin section. And this is not that same rock that we just saw a minute ago, but this is a thin section of dunite. That's the plane polarized light view, and that's the cross polarized light view. And if I flip between them quickly enough, it's like flipping in and pulling out the polars. But of course I have the added advantage of being able to zoom in on this sample, much like a microscope would allow me to do. And I can see the interference colors, and I can even zoom in to a point where I can see the nice little rainbows of interference colors as the thickness of the crystal gets thicker and thinner. Now what I can't do yet is rotate this slide around, but someday maybe we'll find a way to do that. And where do you go from a thin section view? We're already at the micro scale. There's only one place to go beyond that, and that's the nanoscale. And this is a GigaPan that Molly Gibson shot, and it's actually a sample that I supplied to her. This is Reticulate from Hawaii. Reticulate's a form of pumice, but it's so gassy as a pumice that the gas bubbles merge with each other, and the volcanic glass is basically just present at the corners where the gas bubbles were, and Paul Heckbert has actually snapshotted this beautiful little point here where you can actually see where three gas bubbles came together, and you can see those little 120-degree angles on the interior of the gas bubble wall. So that's as far as I can go as far as zooming. I haven't gotten any further than that. What makes this especially compelling is if you can actually get a nested group of GigaPans to zoom. And so this is one that I shot right along the U.S.-Mexican border, actually just north of the Mexican border. This is at Coronado National Monument. You can actually turn around here. This is a 360 view. If you turn around and look in the distance here, where is it? There's the border fence. In fact, they were actually working on the border fence right in this area. This is one of the last areas where it's been completed, but you can see the Mexican border. So there's Mexico, there's the U.S., all in one GigaPan view. You can pan all the way around, see well down into Mexico. Day wasn't quite clear enough to see the Gulf of California, but you might be able to from that vantage point. But I actually wanted to look back in this direction Here, of course, we can see the ever-present Border Patrol vehicles, because even though this is a national park, it's still on the border. But what's interesting to me is the geologist is this nice little road cut right behind there. And this is just about the limit of the zoom on the GigaPan right here. But of course, I hiked back down off the mountain and shot another GigaPan of that subsequently, and there is the outcrop. And we can zoom in here, and now we can see that, in fact, that road cut is made up of a whole lot of angular clast. This is volcaniclastic material. And then, of course, I stepped in a little closer, and I shot a macro up close, and you can now zoom in and see details of the individual clasts, maybe even make out grain size variations. I didn't put a scale on this one, I'm sorry. Bertie and Eddie were staying in the car that particular day. So, and one could extend this with going further and further down. I think that's all the GigaPans I've pulled up right there. The next thing is, how have I actually used these GigaPans? And certainly the simplest way to use the GigaPan is to just integrate it with my lecture notes. And this is what I've done here. This is my Intro Geology class website. I never really learned PowerPoint. I learned HTML, and so I've always done my lectures as just web-based forms. And so what I have here is I would normally have lots of just standard pictures out of your textbook and photographs, but now I have the ability to jump into, in fact, I'll start with the Bear Valley folds. This is actually the first GigaPan I ever stitched before I had a GigaPan unit. This was just a handheld shot that I shot on a lark before I knew GigaPan even existed. Figured I might figure out a way to stitch it in Photoshop, but fortunately I found GigaPan. And you can zoom in and see lots of detail. You can see how this fold nose here rolls over a little bit. And I don't know, there's coal seams and fun things like that to explore. The students really enjoy exploring this. So, I mean, this from an engagement standpoint, just simply GigaPans as opposed to regular photographs are a real value there. Here's the calico folds in California, a nice anticline-syncline pair. Nothing in particular to zoom in on other than just the individual blocks of rock. But anyway, that you can see that's one way of embedding this. Now, taking that a step further, one of the things that I discovered early on that you could do with embedded GigaPans is, and I think I may have even done this initially by accident, is I basically copied the embed code twice instead of once, and I ended up with two GigaPans sitting side by side. It dawned on me that this could actually be useful, and these are, this is one of my earlier GigaPans, and Bertie and Eddie are in here. In fact, I use this to introduce the GigaPan to the classes because, well, there's Eddie, and he's on the outcrop for scale, and Bertie's on this one for scale. And I love to use this one because it allows me to point out, yeah, they're there on opposite sides, but Bertie's actually standing in an Inoceremus shell, which is one of these giant clams of the Cretaceous Seaway. So this is chalk up in Rooks County, just a road cut. The value, though, of putting these things side by side was not just showing the two guys juxtaposed with each other. It was the fact that you've got a small normal fault in here, and it's pretty obvious to a geologist just looking at this what the offset on that fault is. But it suggests to me an exercise in correlation that one might do. So here, we're moving to the footwall of the fault, and I'm zooming in on a portion of the stratigraphy there. And then I'm going to move this side of the fault to the head wall of the fault and zoom in on a portion of the stratigraphy there, and it's that same portion of stratigraphy. And if I do everything right and I get the zooms about right, I can reconstruct those right across the fault. And so that's an excellent example of just correlation in a visual sense done right across a fault zone. So what else could we do with this? Well, how about two different outcrops? Could we correlate between two different outcrops? And these, well, I generally give this to the students now. I've shown them how to do it with the first one. And then I basically, a lot of them have laptops. They'll have seen GigaPans I've shown before. I'll say, go ahead and, do this and see if you can get these two to correlate with each other. And I'll give them 5 minutes and they'll talk amongst themselves and they'll see what they can do. And it's not just a straightforward right across the street I mean, you might think that, well, if I just zoom them top of the outcrop, bottom of the outcrop, it's going to match up, but it doesn't. And when you start zooming in and looking at it, you scratch your head and think, well, maybe they don't correlate. But if you're experienced at this, you begin to recognize, oh, there's a pair of layers, there's a pair of layers, and I can get those to, well, let's see if I can do it right. It's also a little dicey, but yeah, that's close to the same zoom. That's a little bit better. Anyway, I think I'll convince you that you are indeed able to correlate these. And you should be able to, because this is flat-lying Kansas stratigraphy, and these are actually two mirror road cuts right across the street from each other. So no surprise that you would get a correlation across there. The final set is two outcrops of the same formation from about 20 miles apart. And of course I have them do the exercise here, but I've never yet actually gotten a correlation across these two. So if any of you does find that, by all means let me know. So that's an example where the students actually get a hands-on sort of experience with this. The picture here of the hand sample that I did in macro, one of the hacks that I talked about last night, and unfortunately this is better on a big screen. Let me see if I can go full screen. That's a little bit better. What I've got here is just the macro image that you had seen before, and I was inspired by the front page of the GigaPan website to say, hey, I'd like to be able to kind of auto zoom in onto a single spot in that. And I went and I mucked around and hacked with the code and finally figured out how to get this thing done. And so Bertie is going to take you on a little tour of this specific sample. Now, I once actually had a variety of this tour where I actually had audio embedded, but I've broken my own hack and I couldn't figure out how to get that done before I came out here. So I just have written descriptions. And basically what this is just JavaScript. In fact, you can actually go in and look at the source code on this page. And with each jump, there's a new set of text that comes up. Then as we arrive at the new spot, a new thing comes up as we sit there and wait and let you read that. And then he'll take us on to another stop. And it's maybe a little slowly paced for this. But, and there's some Sveen, or Titanite if you prefer. And this is basically where I decided to end the experiment, just simply as a short little tour. Those of you who have been on the GigaPan website for a while, you've seen Kilgore perhaps, Kilgore 661. He has done much bigger things with this. He's taken some of his Bath skyline profiles and done 15-step tours through them as guided tours. So that's another fun little thing, and let me go ahead back here. What have I got next here? Oh yeah, what I've done actually before I come to this, I'm going to come back to Google Earth and go all the way back into Google Earth, and we're going to zoom out of Dinosaur National Monument for a minute. And just a second while we fly back out to a Earth view. Actually, we're going to fly to the Pacific Northwest, so I'll just kind of aim us in that direction. You'll have a sense of where you are now. About 2 years ago at AGU, I presented another talk called GigaGeology. And this was, oops, I don't really want that whole thing done. Basically, this was part of a Penrose lecture that we were talking about different ways of using Google Earth with new technologies, Web 2.0 technologies and such, to enhance geologic education and research. And basically I decided to, for my part of this, make a virtual tour using GigaPans extensively. And so let's zoom in a little bit on Mount Rainier, which is the topic of this particular, this was a GSA meeting in Portland, Oregon, so it was just kind of in their backyard. There's Mount Rainier, and if I do this right, I want to go down here to my overlays, just overlay some geology for you. It'll take that a minute to come in. There we go. There's a geologic map of Mount Rainier National Park, just scanned from the paper map and then overlaid in Google Earth, just to give you a little idea of the geology. We'll come back to that map, But for now, let's just move into the Stevens Ridge GigaPans. I'm going to start with just this one, and this is where I crashed the talk at GSA multiple times, so some of you in the audience may remember that experience. We'll attempt to enter that panorama, and hopefully, oh, good. So far, so good. Yes, that was the point where I crashed it and rebooted and crashed it and rebooted. And so what you're looking at here is, of course, a GigaPan embedded into Google Earth, and I'm going to just I don't want to remove that sidebar for just yet. There's Mount Rainier. It was a little bit hazy that day, unfortunately. But of course, with viewing GigaPans in Google Earth, you have the great advantage of being able to use the transparency slider to see there's the Google Earth imagery, and there's the GigaPan of the real thing. All right, so that's a fun thing to do. And of course, you can zoom in on individual little areas. There's a nice waterfall here. Ooh, pretty waterfalls. I teach my intro students to do that ooh-ah thing. You can feel free to ooh-ah anytime you see something. I don't know if there's really much point in, well, yeah, look at that. You can see the waterfall in the Google Earth imagery, too. This is an area where you got fairly good Google Earth imagery behind things. Okay, I'll wrap it up here real quickly with two things. One thing is that you can also see, and I got to come up here, I'm going to turn on that geology layer behind things. Now, the GigaPan is up front, but I can also do that transparency slider where I'm, oops, I got to be clicked on this first. And let me actually look at Stevens Ridge over here from a little bit further out. So one of the things you can also do here is to change the transparency. Am I not doing, let me click on that again. Let's try it again. It doesn't seem to want to behave. Transparency, no. All right, well, so it's not behaving right now, but what we should be able to do there is slide the transparency slider on the Google Earth imagery and see the overlaid geology behind it, where you can actually see there's a contact on the geologic map that runs down the top edge of this ridge, and actually you can compare that to the GigaPan and see a change in the vegetation right about where that contact should show up. So that's another nice sort of feature. There's an embedded example here of a comparison of two things. There goes the geology. And on this screen resolution, this is not going to work so well because it won't fit in the window here side by side. But this is just two granitoid rocks from different areas of the park where we're simply doing that same sort of correlation thing where you can zoom in and compare them side by side and just see, are they the same intrusive unit or are they different? And you might be able to pick out mineral differences at that level. There's another one here where I look at one of the mud flows from off the mountain compared to a glacial till. And they are very clearly different when you look at them side by side. So again, that's an embedded GigaPan. So that's just some of the stuff we're doing with GigaPans embedded in Google Earth for virtual field trips. I'll get Google Earth out of the way there. And then the last thing I want to end with is just that I have been doing this now for years. I got lots of GigaPans out there. One of the things I enjoy a lot, and I've gotten a lot out of, is blogging about these things and embedding the GigaPans in the blog. And these are just a couple of, my blog here is Ronald's Geology Home Companion blog. I started this blog long ago. I figured that was a good SEO name. It got geology in it, it got my own name in it. It would end up high on search engines. And it's done that, but meanwhile, other geobloggers have come along with really great blog names that make great geologic puns, and I'm left out here with this mouthful. Here are basically embeds that are simply taken directly from the website. If you geolocate your, or if you just upload it, you can go into the edit page and find the code to simply put that in, and that's just put right into a WordPress blog. I've dominantly gone with the old style embedding, and if I scroll down here far enough through the pretty geology, I'll eventually get to a few that are embedded GigaPans. Well, you remember that road cut. Oh yeah, here are the thin sections. So picture thin section, and then the embedded GigaPans. You don't have the blue edges and stuff like that. I also don't have the snapshots in this, but it makes maybe a little bit nicer presentation. And again, you have the ability to do the zooming right there on the site. So blogging is one thing, and of course other social media. I've been tweeting for a while, but Bertie and Eddie are even tweeting at this point. I set up a GigaGeology website. I got the domain GigaGeology. I reserved the Twitter site, and then I wasn't doing anything with it for a while, and Bertie and Eddie just kept nagging me, and I finally let them. Actually, they did it without my permission, but they are now tweeting, and if we simply go back to the previous page, you can see they're now tweeting every day a geologic GigaPan that they find exciting. And so they're social networking, they're making friends, they're friends with some of you already out there. So I think I'll end with that. Oh yes, our group shot earlier on, Bertie and Eddie had the good foresight to smile at the camera. So you'll find them in there as well. So I'll entertain questions if we have time.
We have time for a couple of questions.
Real quick, do you have to use focus stacking for those rock samples?
I have not used focus stacking. The macros that I shot, I selected samples that had relatively little depth of field. I did use autofocus so that some of the back edges and front edges, basically if you use enough overlap and you use autofocus, as long as the center of your image is in focus, when it stitches, it'll do a kind of focus stacking on its own. But no, I have not tried focus stacking. It's just another thing I haven't yet done. Oh, if only I had the time. Any more? Go ahead. The thin sections, actually, I used the GigaPan Stitch software, but they're taking actually shot right down a microscope, and I don't have any motorized sort of sample movement, so that was all moved by hand. That's the old style GigaPanning. It is using GigaPan Stitch software to stitch it together, and it works great. You don't even need very much overlap between them, whereas on photographic GigaPans, I like 30 to 50% overlap between adjacent images. With the thin sections, all you need is 5 or 10% overlap, and it stitches just fine. But they're laborious, and I wish I had one of Rich Gibson's motorized stages.
You may well soon.
Yes, I hope so.
Let's thank Ron again for his talk.
My pleasure.
We're going to begin the single track final two presentations, which are both very special panels. We'll start the next one in 5 minutes, 2:15. It's the science communication panel. It'll be right here in 5 minutes, and I'm going to go get your hand in the other room.